Good afternoon, and thank you for staying. I'm glad that I still see some people here in the audience. It's Friday afternoon, so thank you. What I am going to do today is going to be a sort of like a quick overview of what we do in the context of the enterprise blockchain, right, in IBM. And along the way, hopefully give you some thoughts that may be interesting for your research, potentially collaboration, and separate what is happening in the context of enterprise research in the blockchain space with what you see out there in public, right? So I'm assuming that all of you know something about Bitcoin. So who knows about Bitcoin? Okay, fantastic. Who invested in Bitcoin? Oh, wonderful. So what's the difference between a computer scientist and the like an economy major, let's say, in Bitcoin or in this space, right? So the economy person goes and when hears about that stuff, they go and invest, right? The computer science major, what they do, they go and buy a book, right, to learn about that. And now obviously you may discuss what's a better approach. I mean, maybe like a few months back, investing would be a better idea. Let's see, right? Time will show us. But the point is that Bitcoin, obviously, as we all know it, right, is probably the most famous instance right now of blockchain technology, right? And to a large extent, it has been pretty successful, right? I mean, despite all the badness and the ups and downs, as a technology, it has been relatively successful, right? Now, when you look at the underlying technology of blockchain, and then again, raise hands, who's familiar with the underlying technology? Okay, so half of people probably, right? If you look at the underlying technology of Bitcoin, the blockchain, right, you realize few interesting things, right? So Bitcoin as such is public. Right? Anybody can transact, right? So it's not really permission. Another interesting thing is it's anonymous, right? So therefore you see all these interests, or to a large extent anonymous, right? So you can transact with Bitcoins and without disclosing your identity, right? So that's why there are many of these issues with money laundering and all these things like that are problematic with Bitcoin and some of the cryptocurrencies. When you look at enterprise world, that's exactly opposite of what you would expect, right? So when you interact with your bank, or banks interact with each other, you probably don't want them to be anonymous, right? You probably don't want anybody randomly interacting, like without knowing who they are and whether they can or cannot. You probably want some level of privacy, confidentiality, some level of control, right? More than just what you are getting in the Bitcoin space, right? So that's what is motivating these blockchains for businesses and for enterprises. So think about similar technology, similar kinds of protocols, fundamentally, as in the Bitcoin world, but with like these additional things like identity over anonymity is probably more important angle, some form of data protection, etc., right? Now, quick idea, what is behind blockchain, right? You may have heard about the notion of ledgers, right? Ledgers go way back in history, right? And it's been underpinning businesses for a long time. What blockchain fundamentally is a distributed ledger. That's why in the context of blockchain, you would oftentimes hear the word as distributed ledgers, right? So fundamentally a database, right, that's distributed among many participants. But interestingly, it shares the same data, so it basically replicates the copy of the data to multiple participants. Fundamentally, it does it in an immutable way, right? So basically, once I write something on that ledger, just like you would have done it on a regular ledger, it would stay there, right? You wouldn't, and it's because of the cryptographic protocols that guarantee that characteristics. Obviously, you may, just like in the ledger, you can do update, you can cross the line, but the original information would still be on the ledger, right? So the ledgers are really interesting, right? There's a notion of transaction, obviously, just like in Bitcoin, you're transacting, you're transferring money, but the notion of the distributed transaction is universal. You can transfer any kind of asset. You can take care about like things in supply chain, in financial, doesn't need to be money, right, or currency. And then another key term is a notion of contract, right? Now, I mean the real contract in this case, so why businesses interact with each other and trust each other is because there's some contractual relationships, right, that govern the interactions. So in the case of blockchain, you would want to have a similar parallel of the digital contracts or electronic contracts, sometimes called smart contracts, sometimes called chain code. What it is technically is a piece of code that represents a business logic associated with the transactions that you transact over blockchains. So when you look at the electronic interchange, how do things look like? Obviously, like the multi-party interactions, like on the picture on the left-hand side from your perspective, right, has been around for quite a while, and many aspects of these distributed ecosystems have been digitized in one way or the other. Think about, in the supply chain, about EDI messages, right? That the companies exchange EDI messages. In the financial world, you may think about standards like SWIFT for exchanging financial information. But what is really interesting is that in most of the cases, the distributed transactions rely either on an intermediary. Think about stock exchanges, right? You transact, you buy and sell, you would have a stock exchange in between, right? Or are pairwise. Like, so I ship you something and I send you an EDI message along the way. Somebody ships that to somebody else, again, they will ship the message, which is the symbolic example on the left-hand side with these orange lines symbolically showing these pairwise relationships, right? That works pretty well, but has one major shortcoming, which is that you don't have that shared visibility, right? You don't have that notion of if I send something to you, the third party may not have the same information, may not have an understanding of what is happening, right? So what the ledger, shared ledger of blockchain does on the right-hand side is basically taking same network, technically speaking, and either shadowing that current existing relationships or replacing it or substituting it by that concept of shared ledger. So say that I, again, transfer that package to somebody, I record that on the ledger, and instantaneously that information is available to everybody, right? So everybody has that notion of shared visibility for the transactions. So the four key things that I mentioned here, shared ledger, I spoke about that briefly already, smart contract, I will talk about in a second, privacy and consensus are four things that I will briefly touch on in the next few slides, and then I will go to some business aspects, right? So shared ledger, I spoke about it. It's an append-only immutable database that's distributed across participants. The database could be anything. Right? It could be your traditional database. It could be implemented as file system. It really varies across different implementations. The immutability is guaranteed by that cryptographic chain among transactions. So any transaction that I submit is cryptographically linked with every single transaction before. Right? So there's a notion of chain, right? What makes it interesting is because now if I want to change some transaction, I would have to basically go backwards to all the previous transactions and change all of them just in order to make sure that I can change mine, which makes it increasingly more difficult to do any change. That's where the immutability is coming from. Then the second thing is that notion of smart contracts. Say that I want to transfer $100 to somebody, right? So what I want to make sure is that maybe before transferring the transaction, maybe I need to check whether I have enough money in my account, right? So there is some kind of business logic that needs to happen typically as part of the transaction. Again, you see the parallels in existing systems, right? Like whether it's procedures in databases today, or in business processes, like pieces of business logic, right? So that's really nothing fundamentally new. What is interesting here is that the smart contract is a piece of code that also typically resides as part of the ledger, is also typically cryptographically signed and versioned, also is shared among all the participants. And then important thing is part of something that I have in the bottom right-hand side or left-hand side from your perspective, which is the notion of consensus. The consensus protocol, from the Bitcoin space, proof of work consumes a lot of energy just to make sure that, for example, your transaction is valid. There aren't things like bad cases of transactions such as double spend, right? So I send you $100 and I send the same $100 to somebody else. That would be a bad example of a transaction that you don't want to do. That's a double spend, right? So you want to prevent that kind of thing. So the consensus protocols take care of that bad examples, like bad transactions happening, and make sure that there is agreement among all the participants. So if I submit the transaction to my blockchain, what happens is, A, there is that contract that happens in parallel with submitting the transaction. Until that contract or that chain code logic happens, the transaction is not submitted. That is part of the distributed consensus protocol, right? So every participant in the blockchain network needs to obviously participate in the consensus. Until that consensus is reached, the transaction will not be submitted, right? So that's the high-level idea. And then obviously there are different implementations of that consensus protocols, right? There's the example in the Bitcoin world, proof of work, energy inefficient, pretty expensive. There are other examples, like PBFT and others, right, that exist out there, which basically try to achieve similar effect with higher throughput and less overhead. Important aspect in the case of the enterprise blockchains is the notion of privacy and confidentiality. So I mentioned already that you don't want everybody to see everything. Again, different implementations vary, right, with the level of what guarantees and what characteristics they give to you. Typically, it's a combination of some form of access control, ACLs, with some form of cryptography, right, in place, like encryption, et cetera. So that's the high level. Why does it matter, right? Well, so there's obviously a lot of buzz. People say, hey, blockchain is going to transfer everything, right? So that's if you go out there and you search for blockchain, you will see way too much buzz out there, right? I think practically speaking, if you sort of like when the dust settles, right, there clearly are areas where blockchain can actually lead to, I would call it like a second wave of digitization, right? In the areas, like you obviously see digitization in enterprises, in companies. You see obviously quite a bit of digitization across companies, one-to-one. But then there are areas, the example that was mentioned earlier today, like global trade, like shipping. Like there's so much inefficiency, so much paperwork, many participants, right, that are interacting just, like to make sure that one shipment from Asia comes here, right? And there's a lot of stuff, a lot of disputes. And what blockchain can bring here is fundamentally increasing the level of trust, increasing the level of digitization in these kinds of complex cross-enterprise, of cross-organizational processes. So the hope is that you will basically be able to create new kind of optimization in the ecosystems, right? So that's kind of the promise of the blockchains beyond Bitcoin. We've seen it in supply chain. We've seen it in, let's say, other big example, food safety, for example. It's a big industrial issue, like across like, many countries. Like you want to make sure that, for example, if I have a food poisoning happening, you want to make sure that, you want to understand where, the food is coming from, why did it happen. I don't want to do like a gigantic recall. I want to be precise, et cetera, right? So those are a few examples that make a lot of sense. What I will show you are a few additional examples. So this is just a chart that shows several industries with several references that should give you a sense of where we are currently seeing applications of blockchain today, right? So that sort of like goes a little bit like cutting through that buzz, right? So you would see, obviously, a lot of interest coming from financial services space, like the trade finance, settlement of transactions. There are many, naturally, very, like distributed ecosystem, many banks, many brokers, et cetera. You would see insurances, that's interesting. Again, very unsurprising because it's an interaction between many participants. But then you would see at the bottom the supply chains. You would obviously see healthcare, et cetera, et cetera, et cetera. Right? So these are real, like projects that are happening with clients today. We see that this is a trend that's actually accelerating. Still, having said that, blockchain technology is still in the incubancy yet, still, right? I mean, the technology is pretty young. There's a lot of experimentation. There are obviously several projects that are in production today, but that's not like necessarily these 400 at the top, right? These are like many in development. Just few examples, right? In supply chain, for example, what do you see in supply chain as a typical use case, right? So one example would be notion of provenance of goods, right? So where does that shipment come from? Where does my food, who everybody touched that package of food that I'm buying in my supermarket today, right? And there's all sorts of transformation, processing, et cetera, right? Then you may think about just the pure provenance as a starting point. You may think about certification along the way, et cetera, et cetera, et cetera. And obviously, blockchain plays here the role of the integration of the glue in between the companies. That's one example. The other example, very meaningful, that we hear pretty much across industries, audit and compliance, right? So very naturally, right? Because you're getting essentially a system or technology that's a natural fit for some form of auditing, right? Because once I record something on blockchain with my many participants overseeing what I recorded and agreeing up front, right, that this is the right thing, then you essentially are getting an agreed upon form of truth. And I cannot go back later and say, oh, no, this is not what happened, right? So that's very natural fit for audit compliance. We are seeing it in the cases of, like financial transactions in like filing taxes, for example, right? And taxes preparation. So those are or healthcare, very natural example of that audit and compliance. There are many more, and I will not go there. I mean, we can talk about it if you're interested. All right. Now, we are in IBM, so that was sort of relatively independent from IBM. So what do we do in IBM? And I will try to highlight a few technical areas that may be very interesting for university collaboration and research, obviously, right? So this is a sort of like a pictorial representation of, think of it as a strategy, like a big kind of strategy that IBM is taking in the space of blockchain. So we think that blockchain is sometimes people call it like a team sport, right? And adoption matters, right? And oversight matters, right? Because it's based on, we are trying to infuse trust, right, into these ecosystems. Like blockchain is trying to infuse trust fundamentally, right? So we are starting with at the bottom layer with an approach where we think, you need to have some form of solid foundation, right? So that ideally shouldn't be built by one company, should be in open source, et cetera, should be governed by many companies. So that's the bottom layer, Hyperledger. Hyperledger is a Linux governed foundation, has multiple projects. One of them is Hyperledger Fabric. There are many others, right? That give you if you think about it as a middleware, the foundational layer, right? Oh, sorry, that was too quick. Then obviously we are building that's for free. You can download it today, right? You can play with it today. You can contribute to that today. Then we are building obviously some kind of additional levels of the middleware on top of it, which are hosted, for example, as cloud services. And then obviously we are building with partners these solutions, right? So that's a high level of things. So think about these Walmarts, Maersk, et cetera. Hyperledger is the Linux Foundation project. At the right-hand side, you see several projects there that are under same foundation. So you would see some stuff that's led by Intel, for example. There are some other projects that are led by us and by the community with different focus, right? Most of that stuff is focused on the foundation, but there's a recent project, for example, focused on performance measurements, right? The Hyperledger has around like 230 members. Some of them are academics, most of them enterprises. So you see pretty much, like all over the map, which is good, right? We want to have really many participants there, obviously, so that you get the broad support. I mentioned Fabric. That's if you wanted to start playing and experimenting with blockchains today, this would be the good starting point, right? So you can download it, you can play with it, put it on your laptop as a starting point. If you want to develop something high level, like a quick, hands-on experience, maybe you don't want to be hacking some low-level code. Maybe you want some little bit like a higher-level abstraction, sort of like a parallel of a Visual Basic as opposed to assembler, right? So maybe you want to get something this is the Composer, is a project that allows you to do higher-level, faster development in JavaScript, essentially, right? So it's relatively easy, quick. And then obviously, I'm from research, right? So I'm here to basically tell you about all the exciting stuff that we want potentially you to work with us on research-oriented topics. So research basically spreads across the different topics that I mentioned before in the context of blockchain. Starting from, and then it's a bullet point, right? So I don't need to go through everything, but starting, with the performance and scalability, because as I mentioned, this is a very early, relatively very early days for the technology. So that matters, obviously. Security, privacy, confidentiality, big area of interest as well right now. So I spoke with some of you a few minutes ago. So that's a big area where we can work together. Data management is very interesting, right? So you currently, typically what happens is that you take some existing database and use it as part of a blockchain. Hyperledger Fabric is open in the sense that you can plug your own database of choice if you want, right? Now, some interesting areas are basically on the edge of blockchain and other technologies, right? So one area is some form of secure AI, secure trusted AI, and blockchain, right? The other area that we are looking at is secure IoT integration. So the previous talk was really exciting, looking at IoT. Now, when you think about blockchain, right, it's immutable, but if the data that you're feeding into blockchain is garbage, right, you get immutable garbage, right? So, which is not that particularly useful. So you would ideally like to have that endpoint device is trusted, right? Just like you have had before, and integrated with your blockchain in a trusted manner, right? So that's sort of like that notion of, okay, what is the good interplay between IoT and blockchain? So those are just few examples, and obviously, a lot of interest in building innovative applications, innovative solutions, right? That's pretty open as well right now. So I'll pick one. I thought I'd pick one example project that we work on. Just recently, we had like a little press release of a tiny device. I mean, we like to call it the world's smallest computer. It's in the end of the day, it would be a device that would have, I think 100 by 100 micrometers size. It's a full-fledged computer built with the latest chip technology. Now, we are not quite there yet, right? So it has a roadmap, but we have prototypes right now. So what you see on the picture at the bottom is like a little prototype of the device. Currently, it's like 1 centimeter by 1 centimeter, but it's, the scaling down is happening very fast. And we're enabling the device to be running with blockchain in mind. And we have a little demonstration prototype that basically integrates the device with blockchain today. Now, obviously, this is really very early, right, with these kinds of devices, right? So it's slow, the security is okay, but could be better. It doesn't have sensors right now because it's a tiny device. So there's a lot of area, a lot of work that can be done in this space. But I just wanted to pick one example where I think it's kind of very exciting and more on the research side rather than something that's like building like food trust or food safety networks with Walmart, right? So that's all what I have. I don't know how much time we have. We have like a few minutes behind. So thank you very much. And